Lesson 2.6, Ratios, Rates, and Conversions. Ratio, the comparison of two quantities by division. You can also think of a ratio as a multiplicative relationship. For example, if the ratio of the number of boys to the number of girls in a class is 2 to 1, then the number of boys is 2 times the number of girls. Rate, a ratio that compares quantities measured in different units. Unit rate, a rate with a denominator of 1 unit. Conversion factor, a ratio of two equivalent measures in different units. A conversion factor is always equal to 1. Unit analysis, including units for each quantity in a calculation to determine the unit of the answer. You can also write ratios and find unit rates to compare quantities. You can also convert units and rates to solve problems. Problem 1. You are shopping for t-shirts. Which store offers the best deal? Store A, $25 for 2 shirts. Store B, $45 for 4 shorts. And Store C, $30 for 3 shirts. Write each price as a ratio, then write the ratio as a unit rate to compare. So a lot of this can seem like common sense. We want to figure out, we can't determine right now which store has the best deal because they all their prices are for different number of shirts. So if we create a ratio, store A kind of looks like a fraction, $25 for 2 shirts. And if we divide 25 divided by 2, we would get $12.50 for 1 shirt. We could do the same for store B and store C. So store B, the ratio is $45 for 4 shirts, and that would be $11.25 for 1 shirt. And store C is $30 for 3 shirts, so if we figure that out, it would be $10 for 1 shirt. So now that we have the prices for each store for 1 shirt, we can determine which store offers the best deal, and we can see that store C has the best deal because its unit rate is the lowest. To convert from one unit to another, such as feet to inches, you multiply the original unit by a conversion factor that produces the desired unit. An example of a conversion factor is that in 1 feet, 12 inches. 1 feet is 12 inches. Problem 2. What is the given amount converted to the given units? 330 minutes, 2 hours. So here we want to choose and multiply by the appropriate conversion factor. The appropriate factor will allow you to divide out the common units and multiply and simplify. We're going to do more with this tomorrow, okay, when you come into class, because this topic along with the next problem is very detailed. So just follow along and copy your notes for now. It's okay to be confused. So in step 1, you want to choose a conversion factor. We want to go from 330 minutes and we want to figure out how many hours is that. Instead of sitting there trying to figure it out, you can just set up a conversion factor. Whatever unit is given to you, put it over the number 1. Now we want to figure out a conversion factor that would eliminate minutes. That means if minutes is in the numerator over here, in order to eliminate the word minutes, minutes has to be in the denominator here. Well, the conversion factor between minutes and hours is in 1 hour there are 60 minutes. So the conversion factor over here is 1 hour over 60 minutes. And then you just multiply across, because if you get the units, the word right here, hour, that you desire, you do not have to set up another conversion factor. So step 2, divide out the common units. So minutes cancel out. And step 3, you are going to simplify. 330 times 1 hour is 330 hours. 1 times 60 is 60. 330 divided by 60 is 5.5 hours. This lesson involves units, so you need to make sure your answer is in the appropriate units. You can also convert rates. For example, you can convert a speed in miles per hour to feet per second. Because rates compare measures in 2 different units, you must multiply by 2 conversion factors to change both of the units. Again, this problem is very detailed, so I'm just going to run through it pretty quickly, but we will spend a lot of time tomorrow, and I'll show you in the sample problem later on how to do it. A student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. So here's what we know. We know the running speed in yards per second. We need the running speed in miles per hour. our plan here is to write the speed as a ratio. We are going to choose conversion factors so that the original unit, yards per second, divide out, leaving us with the units we want, miles per hour. So in other words, we have to convert yards to miles, and we have to convert seconds to hours. Sometimes you're going to use more than 2 conversion factors. Other times you're only going to use 1. So 50 yards per second is what we put. 50 yards per 5.8 seconds. So let's start by converting yards to miles. The conversion factor we will use is 1 mile is 1,760 yards. Again, tomorrow you're going to get a conversion factor sheet with a lot of these conversion factors. Okay, we will put miles in the numerator and yards in the denominator so that yards cancels out. Right here. Okay? Next, now that we converted yards to miles, that's good. We have the desired unit right here. We need to convert seconds to hours. So in order to do that, right down here, we can just write the next conversion factor next to it because yards is going to cancel. There are 3,600 seconds in 1 hour, so seconds cancel. So now we're left with the units we want. Miles in the numerator, hours in the denominator. Multiply across, 50 times 1 times 3,600 is 180,000 miles. 5.8 times 1,760 times 1 is 10,208 hours. And if you divide it out, it's roughly 17.6 miles per hour. Okay, so let's do a couple of practice problems here. Number 1, what is 1,250 centimeters converted to meters? So we need to go from centimeters to meters. We don't see the word per, so we're going to just put our original unit over 1. The conversion factor we're going to use here is going to be 1 inch. We have to actually use 2. 1 inch over 2.54 centimeters. So that's centimeters cancel. And the other conversion factor, we have to go from inches to meters, is 1 meter over 39.37 inches. And again, when you get the worksheet tomorrow, you're going to see all of these. And then if we multiply across, I'm just going to give you the final answer. Okay, it's going to be 12.5 meters. That's if we multiply the numerator, multiply the denominator, and divide. Number 2, a building is 1,450 feet tall. How many meters tall is it? Use the fact that 1 meter is 3.28 feet. So here they give you the conversion factor, and we only have to use 1. So 1,450 feet over 1 times 1 meter. So we want meter in the numerator over 3.28 feet. Cancel out the word feet. And again, the final answer you're going to get here is 442.07 meters. Let's look at one more. An athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? Round to the nearest mile per hour. So this one is like the problem we saw before. So we know the speed in feet per second, and we wanted to convert it to the speed miles per hour. So that means we need to convert feet to miles, and we need to convert seconds to hours. So we can do this in 2 conversion factors. You can do this in 3. So we're going to write the first one that we know. We know it's 100 feet per 3.1 seconds. So based off the conversion factor sheet that I'm going to give you tomorrow, okay, in 1 mile, there are 5,280 feet. So we don't need to worry about doing anything else from feet to miles because we already did that. If you know off the top of your head how many seconds there are in an hour, that'll just take you 1 more conversion factor. If not, you'll have to go seconds to minutes and minutes to hour. But the common one is 3,600 seconds are in 1 hour. So you can cross out the word seconds. We have our desired units, miles per hour in the appropriate areas. And if you multiply across and divide, you are going to get roughly 22 miles per hour. Because remember, they said round to the nearest mile per hour. All right? Again, it's okay if you're confused with all the stuff we just talked about. We're going to do a lot more with this tomorrow in class.